Hello dear students, I'm Ajay Karmarkar. Before starting this video, I would like to say something. Please sit with copy pen. If you find somewhere important, then note it and proceed further. And although you have facing any problem or difficulties, please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe my channel that can reach more and more students. Thank you. Now here is the question. In the given figure, the block is attached with a system of three ideal springs A, B, and C. The block displaced by a small distance small x from the equilibrium position vertically downwards and released. Capital T represents the time period of small vertical oscillations of the block. Here, pulleys are ideal. Choose the correct alternatives. Here we have given four options. The options are t equal to t here time period t equal to 2 pi root 11 m by 2k. Option B, the deformation of the springs A is 2 by 11 times the displacement of the block. Option C, the deformation of the spring C is 1 by 11 times the displacement of the block. And option D, the deformation of the springs B is 4 by 11 times the displacement of the block. This is multiple choice question. Okay. Let's see what the question says. Here at the pulley A and here the B, the spring is connected A, B and C. Spring constant is K, and between B and C, that is spring is connected, that is spring constant is K, and here the spring constant, that is 2K. Okay, and this mass M is hanging, and the bond is, there is rigids, that is connected as per the constant rule. Here the tension T is applied, then tension T and tension T. Now it becomes tension 2T, and again 2T is divided into equal parts because all the systems are in equilibrium. And let us consider the here elongation of this spring A, that is x1, and elongation of this spring B, that is x2, and here the elongation of the spring C, that is x3. Okay. Now, as for the constant relation, what says the constant relation? When the two ends is fixed or rigid and if we have to apply some force, then its elongation is directly proportional to the force, because force equal to kx. Here the force is tension, so therefore kx, so therefore T is directly proportional to the x. So this is the constant relation. So here you can see that tension T, so it is its elongation is x1. Here 2T, so therefore its elongation is 2x2. So net elongation is x considered because it is given in the question. So x equal to x1 2x2 plus x3. Okay, consider it is the first equation. Now here at the A, tension is T, that is equal to kx1. So x1 can be written as T by k. And at the B, the tension is 2T and k into x2. Then x2 can be written as 2T by k. And at the C, again the tension is T and spring constant, that is 2K, and elongation is x3. Then x3 can be written as T by 2K. Okay, now substitute all this value of x1, x2, x3 in equation first. What is the value of x1? That is T by k. What is the value of 2 into x2? That is 2T by k. And x3, that is T by 2k. Taking the LCM 2k, here 2T, k divided and 2, 2 2s are 4 2s are 8. 8T, and that is T. So net elongation 8 into 10 and 1 11. 11T by 2k. Okay. Now here, this is capital T's tension force. And tension force can be written as mass into acceleration. Now substitute this value of x11 mass into acceleration upon 2k. Now Here T is the tension force, and we know that tension force equal to mass into acceleration. Now substitute this value, x equal to 11 upon 2k, and what is the value of tension? That is mass into acceleration. Then acceleration can be written as 2kx by 11m. Here we know that relation between the angular velocity and the linear acceleration, that is a equal to omega square x. Here x is the displacement for the oscillation, and now by comparing this first and second, you can see that here the x coefficient, that is 2k by 11m. So omega square equal to 2k by 11m. And what is the value of angular velocity omega? Omega is 2 pi by t. It's a whole square, 2k by 11m. Okay, so 2 pi by t equal to root 2k by 11m. Then t can be written as 2 pi root 11m by 2k. So here, that is the time period, 2 pi equal to t equal to 2 pi root 11m by 2k. Okay, so all these answers we can see that now. Now we have already find out x equal to 11t by 2k, and it can be written as in the form of tension force. Here T is the tension force. Okay, so tension force, that is equal to 2kx by 11. Now we have already find out this x1, x2, x3 in the form of tension force, our previous part. Now substitute all this value of tension, then we get 2kx by 11, and k, here k cancel out, then 2 by 11k 11x. Similarly, here 2 by k, now substitute all this value, 2kx by 11, then k cancel out, then 4x by 11, and here again 1 by 2k, now substitute this value, 2kx by 11, then 2k cancel out, 1 by 11x. So here x1 is 2 by 11 times of the total displacement. Here x2 is 4 by 11 times, then x3 equal to 1 by 11 times of total displacement. So now here options are t, time period equal to 2 pi root 11 by 2k, that is also correct. Here option B, the deformation of the spring A is 2 by 11 times the displacement of the block, that is also correct. The displacement of the spring C is 1 by 11 times of the displacement of the block, that is also correct. And last, the deformation of the spring B is 4 by 11 times the displacement of the block. So therefore all the options are correct. Okay, I hope so you understood this question. Thank you for staying till the end of this video. Definitely for your success, all the credit goes to your hard work. But if my video will help for your success, then I will consider myself lucky. Thank you once again. Take care. Bye bye.